First of all, welcome to everyone, and thank you for joining us. I'm really excited and very happy. Thank you, David, for accepting this invitation and for being the first of our new webinar series speakers. Thank you very much. I just wanted to start with a couple of announcements for the society. So take this occasion for us to say a couple of things about what's coming up with the society. So first of all, there is an online, a virtual conference. And here we have to thank Kara Morgan for organizing and proposing this. Would be a joint event between Decision Analysis Society and the Society of Risk Analysis. And it's a very timely conference on emerging risks. It will be on June 22nd, 23rd, virtual, with a very swift organization. So it will be not a heavy virtual conference, but something nice to enjoy. Then we have our next webinars on March 23rd. So for your agenda, same time as today, March 23rd, will be Manel Bauchels from Dartmouth Business School. And May 20th, 2021, will be Yan Chen, University of Michigan. So our next two webinars will be on March 23rd and May 2021. And of course, there will be the Decision Analysis Society Conference, ADA 2022, will be in June. I think the date will be June 27th, 30th, 2022 in Washington, D.C. Later on in our calendar, but so this year, as you know, we could not arrange it because we wanted to have an in-meeting conference, but it will be this year, next year. This year, we will have the June DAS SRA conference. So that's all for now in terms of announcements. So these are our main announcements. I'll stop sharing my screen, and I am honored to leave the floor to Professor David Bell. As you know, he has a PhD in mathematics from, an MSc in mathematics from Oxford, a PhD in operations research from MIT. Then he has been professor at Harvard for most of his career, and I'm proud to say he's also a Ramsay medalist, and he was awarded, in fact, the Ramsay medalist of the Decision Analysis Society. And I leave immediately the floor to David. I don't know if you have to share some screen.
But let me start by thanking all of you for joining it. To be honest, I didn't expect all my old buddies from way back to be on the seminar, but it's great to see you. It makes it seem more like I don't know, more of a get together, more of a real seminar than just me pontificating. I've told this story before, but the first time I came across decision analysis, it was finding Rafer's white book in a library, in my college library at Oxford. But when I got to MIT, Ralph Keeney, who's a young assistant professor there, got me interested in utility theory as a real research subject. And I have been at Harvard for 44 years, something like that. And probably one of the main stimulations for going there was because Howard Rafer and John Pratt and Robert Schlafer were there. I've been teaching marketing for many years at Harvard Business School, and I'm just getting back into teaching decision analysis. A lot of fun, and this has come out of that. I thought I actually am doing some research at the present time, but when Emanuela said, could you give a talk to start this series off, I thought I'd just like to go back and revisit some of the stuff I did a long time ago. If you read my little blurb on the talk, uncelebrated, I think I described it. We'll see if I can make it any more celebrated than it has been before. So why don't I just get on with it? I have no idea how long the talk lasts, and then we can chat at the end. So I do share my screen. I know from years that it's difficult to read slides and listen to the speaker at the same time. I'm hoping that really you can get by just by listening to me, but as you wish. I'm going to can I make this smaller? Never mind. I can't see you now, that's the problem. No, that's much better. Okay, so the problem of sort of what shape the utility function for wealth should be. Here's my notation, which use obviously the utility function. I like to make a big deal out of W, the current wealth, and X is the incremental payoff of whatever gamble you're looking at. X with a tilde over is the actual gamble, X is the payoff. So I think of the utility function as of W plus X. I'm not saying this is a two-dimensional function, it's a one-dimensional function. So there's nothing special except me denoting the W for reference. So we're generally trying to decide between two gambles, X and Y. Again, the way I think about it, we're trying to decide between W plus X and W plus Y, because W is my initial wealth. That looks like exactly the same thing. I hope they aren't all twice. So when I was at MIT, it seemed, looking back, I think these were the properties of the utility function that I remember from then. Wealth, most people, let's not worry about weird cases. Most people are going to prefer more money to less. Most people are going to be risk averse. I think decreasing risk aversion was, well, it certainly was a thing. I'm not sure how many people would have written it down as a big assumption, but. And I always remember John Pratt insisting that utility function for wealth should be bounded. And his argument, and here I'm sure many people made the same argument. This is sort of me reminiscing as much as anything. The argument is this little decision tree I've got at the bottom here. Whatever your standard of living is right now, imagine you have you would take this lottery where with some small probability you get untold riches, any amount of money you want to write down, or most likely you live in poverty. I'm guessing nobody in this room, written as Zoom, not room Zoom, would actually take this bet, which shows that utility is bounded. The only result I remember, I mean, I'm sure there were other results, but the only one that stood out in my mind was this one by Van Segel, who I see I discovered died 2 years ago. But anyway, the idea is that if two gambles, you're indifferent between two gambles or whatever the order is preserved when you translate wealth. So I have a certain opinion, I rank two gambles, X and Y, and I add, if my wealth changes to some other number, the ranking between X and Y is unchanged. And good old Van Segel showed that if that was true, and I think there was, at the time, I think there was some sense this might be a kind of reasonable universal truth, then use either linear or exponential. Of course, exponential doesn't satisfy decreasing risk aversion, but that's what I say. I don't think decreasing risk aversion was too big a deal at the time. Another assumption that I don't remember being made a kind of a big deal, but was implicit, I think, in everything we did, particularly in teaching, was risk aversion goes to zero as wealth goes to infinity. Because we always used to say the reason we were using EMV, expected monetary value, in decision analysis exercises was this is how you would decide if it weren't for risk, or if you're really rich and you don't, if you don't care about risk because you're really rich. So I'm assuming that all of those are not very controversial. So let's go back to the basic problem. We want to decide whether to pick X or Y. And let's suppose we've got the utility function. Let's not say that that's uncertain. We know your utility function, and we know your wealth. And the expected utility of X is bigger than the expected utility of Y. Do you pick X or Y? I'll leave you to think about that for a minute. The answer is not pick X. If X is preferred to Y for all W, then it is true that you should pick X. But that's not true if for some values of wealth, X is preferred, and some values of wealth, Y is preferred, as shown in this illustration. So actually, I was just looking this morning. Well, let's suppose that. My assistant typed these up. You should have seen my handwritten versions. Suppose that you have this choice between X and Y, but you aren't going to decide yet. Maybe you've got a week to think about it. In the meantime, you're facing other decisions. What is your utility function conditional on the fact that you have yet to resolve X versus Y? So you're going about your business. Now some other gamble comes along, Z. Well, it's this thing. It's, oh God. Oops. It's this function. My handwriting's terrible. My drawing's terrible. It's the max of those two functions. And in my great master's thesis, written under the supervision of Ralph Keeney, it's theorem 4. Must have seemed profound to me at the time. But it is the utility function in the interim, while you're still thinking about X versus Y. Your utility function for new opportunities is this, well, yeah, taking it away, odd-shaped thing. But if that's your utility function for future gambles, that of course is not concave. And therefore, you are risk prone in that region where it's not concave. So what you could do, and indeed should do, is before you decide on X and Y, you should take an additional gamble, voluntarily take an additional gamble preferably between, if you can read this, the 2 points W0 and W prime that are on the bottom axis. In other words, you should concavify your utility function so that there's a tangent between the two curves. And you can do the concavication by coming up with somebody who will give you a lottery between W0 and W prime. And so when I said the utility of X is bigger than the utility of Y, what do you do? And you're supposed to say, I pick X. The answer is no. What you do is you look to see if current wealth is in the risk-prone region of these two curves. And you go to Las Vegas or somewhere and get yourself a 50-50, not a 50-50, excuse me, a lottery between the two tangent points. And you undertake that lottery willingly. And then if you win the lottery, you pick Y. And if you lose the lottery, you pick X. So I'm bringing this up to show that when we're thinking about what shape should the utility function be, we all have decisions that we could make that haven't. Things that are available to us, but we have not taken advantage of. You could start a company. You could load up on stocks more than you have. Whatever. There are lots of things you could do but haven't. Options out there. And so your utility function could be, you know, weird shape, depending on what those options are. I'm just saying. So it could be that when we think about what your utility function should be, there are unresolved options in your background that screw up the utility function. There might also be unresolved uncertainties. So W is, you know, the way I always think of it is it's some known quantity. How much money do you have, kind of thing. What is your wealth right now? And naturally, most of us have no idea what our, well, not no idea, but we certainly can't name to the dollar what our wealth is. There's all kinds of uncertainties. But suppose you have two particular uncertainties. These are more or less the ones I used in the introduction to my paper. So I assume you may, that your aunt, unfortunately, your aunt has died, but on the plus side, she may have mentioned you in her will. And there's a 50-50 chance in your mind that she's left you 40,000 or not. This is very specific, I understand. And you also have a slightly out of date coupon from your dry cleaner for $10. And you know, you're going to go around and see if the dry cleaner will accept it. So your wealth is certain, except you've got these two uncertainties. One is whether you're going to get 40,000 from your late aunt, and the other is whether the dry cleaner will honor your coupon for $10 off. And in each case, you think it's a 50-50 chance of these things happening. So now you're about to decide between X and Y, which is the standard issue. If X is better than Y for all W, then we're in the land of Van Sadel. And we don't, for the purpose of deciding between X and Y, we couldn't care less whether the aunt leaves you the money or not, because you're going to make the same decision. But otherwise, if it's like the graph I had before, where for some values of W, X is better, and some values of W, Y is better, then it could be valuable to know the outcome of these gambles. And which one, oh yes. So it's true that it can't harm to resolve these gambles ahead of time. I mean, before making this critical decision between X and Y, it might be worthwhile trying to find out if your aunt is actually leaving you the 40,000 or not, and maybe even a trip to the dry cleaners. But what I'd like to think about is if you could only resolve one of these uncertainties before you decide between X and Y. Would you rather know whether your aunt is leaving you the 40,000 or whether the dry cleaner will honor the $10 coupon? And I assume you're not thinking too hard about this question, because it's obvious, I'd say, that you would like to resolve the bigger gamble rather than the smaller gamble. So actually, the condition I'm going to impose is that whenever you have two background uncertainties, unresolved uncertainties in your wealth, and one is bigger than the other in the sense that the shape of the uncertainty, the density function, is the same general shape, two normals, two uniforms, two 50-50 gambles, whatever, that you'd always rather resolve the bigger one than the smaller one. Why would I really don't see why you, well, I do see why you would, but the assumption seems pretty innocuous. So here we go more formally. We're trying to decide between X and Y. Our current wealth is W plus two unknown, yet unresolved uncertainties. Z1 and Z2 are independent. They have the same distribution, except that Z1 is a larger spread. So it turns out this property only holds. It only always holds if your utility function is linear plus exponential. There are two or three others, but they don't satisfy you increasing risk aversion, things like that. So I threw those out. It's kind of surprising. And the result, you know, I said normal distribution, uniform. Actually, the result only needs 50-50 gambles to prove this. And then the others come along for nothing, kind of thing. So just to be clear, if you tell me any other utility function that you might consider using, if it isn't this family, then I can construct an example where you would rather resolve the small gamble rather than the large gamble for some constructed situation, but still nevertheless a situation. How could that possibly be? Well, the answer is that if the utility function is not sufficiently well behaved, there can be instances where you'd really like to know where you are in some particular region of the utility function. So this function is well behaved in this sense. So I threw this in this morning. So I hope you all agreed. I mean, I can't see anybody, so I don't know whether you're nodding or shaking your head in disgust or whatever. That risk aversion goes to 0 at infinity. So we're all, as we get richer, we get more and more, that the EMV becomes more and more a reasonable thing for us to use in decision making. So let's suppose you're deciding my standard graph, the one where the eventually for higher values of W, Y is more preferred. It must be that the one that's preferred for higher levels of wealth has a higher expected value than the one that you're now passing up. So if I'm choosing between X and Y, and for my current level of wealth, I prefer X. And for higher values of wealth, I would prefer Y. It has to be that Y has a higher expected value than X. Because Y is preferred if you are rich and don't care about risk. Then why at low values of W do you like X? It's because Y has too much risk for you. And so as you increase, you always switch from the gamble with a lower EMV to the gamble with a higher EMV. It's great because I'm not allowing you to talk. Because although I presented this as an obvious fact, it's not, again, true. The only function that has this property is this one again. So again, just to put it in the negative, as it were, that give me any other utility function and I can construct an example where as your wealth goes up, you switch from the alternative with a higher expected value of X to the one with a lower expected value, which I don't think is a sensible property. All right, so here's my last, I think I said I was going to do 3 topics. Here's the last one. So strength of preference, it's a very attractive thought that you can think instead of thinking about utilities, assessing utility function through gambles, that you think about it through strength of preference. So do I gain more value from going from $100,000 to $200,000 or from $200,000 to $400,000? So if I was earning $100,000 and my boss says, I'll give you 200 if you work 15 hours a week extra or something, how exciting how tempting a transition is that? And supposing I was earning 200 and I was offered 400 for working 15 hours a week, is that more, you know, obviously these are 2 different situations. Is that more tempting or less tempting? And the argument about strength of preference always is that you have no real way of testing these statements. If I say those two are about the same for me, there's no real way of testing it. And the great contribution of von Neumann Morgenstern was to come up with a way of calibrating cardinal utility functions in ways that could in principle be tested. Because you can, in principle, offer somebody a lottery and see what they do. But nobody ever does. Nobody ever actually does offer people, it's too expensive to offer people gambles to make sure they've got the right utility function. But still, I think strength of preference is worth thinking about. Oh, so here's the problem. So let's suppose I've asserted that 100,000 to 200,000 is the same as 200,000 to 400,000. But when I go to the gambles, I discover that your certainty equivalent is 150. Why the difference? And maybe this is an obvious statement, but it's because people are afraid of the risk. So when you're considering going from 100,000 to 200,000, there's no risk. I mean, there is in some sense. I mean, there's a risk of what that money is going to mean to you, but let's not worry about that. But when you're looking at the gamble, obviously now you're nervous that you're going to do the wrong thing. So that would suggest that strength of preference and utility, von Neumann Morgenstern utility are measuring different things. So I say my original theory, but just the way I was thinking about these things in the good old days is, let me go back to this. So if I say that 150 is indifferent to 50-50 between 400 and 100, what I'm saying is that if there's a 50% chance I can go from 150 to 400, and a 50% chance I would go from 150 to 100. That hang on. That's a certain stimulus. I'm about to take this risk, and I'm thinking to myself, I might go from 150 to 400, or I might go from 150 to 100. I'm really nervous about that. So the thought is that if I replace those increments by increments that are equal, so instead of 150 to 400, it's now 600 to 1,000,000 or something. And instead of 150 to 100, it's now 600 to 200 or something, whatever equivalent transitions would be. That the risk is still the same, that I'm still facing this certain amount of upside and a certain amount of downside. So the idea is that if I can, my thought is that if you substitute equal increments from a strength of preference point of view, whatever that your attitude to the risks that the risks you're afraid of are the same. You've got a certain amount of upside value increment and a certain amount of downside value increment. And if you're rich, those upside transition and downside transitions are going to be much bigger because you're more wealthy. But from a value point of view, they're exactly the same. So if I say that if I take a lottery and convert all the endpoint values into strength of preference values, V of W or S of W or something, if I raise all those numbers by a constant value increment, then the riskiness of it, this is just me thinking about it, the riskiness of it is the same. Because I've got the same chance of going up, I've got the same chance of going down. Whatever's whirling around in my mind is the same. So it seemed to me that von Neumann-Morgenstern utility was either equal to V of W or equal to exponential V of W. So the sense, so Van Segel was right, but in terms of V, not in terms of W. And the C, I called intrinsic risk aversion, because it seemed to me that this C was how nervous a person you are. Some people, take risks and they don't seem to worry about it too much. And others get paralyzed with fear. This C captures it. That was the idea. And V of W could be valuation of value function for money. It could be valuation for health. It could be valuation for anything. C was your intrinsic risk aversion. It seemed like a great idea. I still think it's a great idea. I'm not sure it's true. So the original plan was that I was going to show that a person who had a lot of fear of risk, was afraid of taking risks psychologically. If a decision analyst assessed their utility function, not realizing that their answers were influenced by all these psychological considerations, they would instead of assessing U of X as equal to V of X, they would assess it as e to the C V of X. That was the idea. But after I tried this, it didn't actually work. So I tried, if you look at number 3 here, that this is my regret formula. If you say that if I end it with X, but I could have had Y, if I take the gamble and I get 100, I realize I could have had 150. Then my utility is equal to the strength of preference value for X, plus something that acknowledges the regret I feel that I only got X when I could have had Y. So I come up with these formulas for regret and later disappointment. This grand theory that if you assess the utility function not realizing that the way the decision maker is actually thinking about this stuff is the way I show here, doesn't end up with e to the C V of X, which was a disappointment. So I had this example, which I'm now going to relay to you. Suppose someone is an investor, is off on a cruise for a month and is out of touch. This is a story from 1980 when you could be out of touch. And the investor has left their agent in charge of decision making. And because this is decision analysis, this is a weird scenario. Some mysterious benefactor gives the agent, gives the investor, but the investor's not there, so gives it to the agent. And it's a gamble. And the agent has to decide whether to accept this gamble. And the investor, this is a very complicated story. The investor has left behind his strength of preference function, the V, and his utility function, the U. And the agent notices that analyzing the gamble, the expected strength of preference, as it were, let's say he says, don't take the gamble. And it's better if he says, does take the gamble, but the expected utility says, don't take the gamble. What do you do? Well, you can certainly argue, and probably correctly, that if the investor were actually here to do this, well, it wasn't on vacation, the investor, by definition, should be using the utility function and reject the gamble. Oh, I've forgotten you another complication. It's a really clear example. The benefactor says that if the agent takes the gamble on behalf of the investor, that whatever the outcome is, the agent just leaves a check for that amount on the investor's desk. So in this complicated I'm trying to create a scenario where in one situation, the investor experiences all the risk of taking the gamble, and in the other, he doesn't. Because in the scenario I have constructed, the person comes back from the cruise a month later, sees a check for $700,000 on his desk, has no idea how the 700,000 came about. There's none of this regret and disappointment floating, or anxiety, anything else. There's none of this psychology roaming around. So I'm sort of thinking the agent should use V, not you. So in this example, which you've been staring at, I think there are sort of regret and disappointment implications for all the payoffs, but the main one is if you take the gamble and only get 100, you have a regret. It says you didn't take the 150 when you had the chance. There's disappointment that you didn't get the 400. And this explains why the 150 is not the 200. So my bottom line is that I think, unless when we do Q&A, you're probably going to tell me I'm wrong, but I think utility from a sort of economic point of view should be equal to strength of preference. And that the things that differentiate U and V are psychological concerns that should be treated separately. Because I don't think they fold into the axioms of von Neumann Morgenstern. They're just floating around, making things more complicated. I'm sure it's not the only reason we get a lot of ambiguities in assessing utility functions, but it probably is one of them. So even if you say, oh yes, finally, everything is clear to me, U of X is V of X, yes, I got it. V of X is still your utility function, still the previous points I brought up are still true. So your valuation function, your utility function is your strength of preference function is linear plus exponential. But I would assess it using strength of preference methodology, terminology, not the gambles, because I think, as I say, I think the gambles bring in the all the psychology stuff. There's one remaining issue, and that is that this function is not bounded, which is why I made a big fuss of it. Big fuss of Pratt admonishing me in the early days that utility function shouldn't be unbounded. I think I would ignore the unboundedness. A, because it suits me, but B, because I think one of these problems with the unboundedness argument is if you start talking about getting $1 trillion or something like that, there's a lot of boundary effects. I think you have to assume that all payoffs are such that the rest of the world stays constant. But if I got $1 trillion, I think the rest of the world would be influenced. I'm making that part up. I guess I would rather live with the properties of this linear plus exponential than worry about boundedness. I think that's it. Okay. Many people are still here. Can we open it up, Emanuela?
Yes, sure. So if you activate your microphone, you can ask questions directly to David, or you can, if you want to write them in the chat, I will read them. But let's open the floor and then have a discussion. I think this would be really exciting. So thank you.
Well, I know James has studied this stuff. Sorry.
Manel wants to say something. Manel, please.
Thank you very much for going over these very fundamental notions. I have read these papers, and then one notion that I find very appealing is the idea that people are really averse to going bankrupt, and that of their wealth, they set up maybe a fraction of their wealth. That's the most they are willing to lose. And that that the utility will then go to minus infinity at some finite value. Then I think you have versions of all these with multiplicative returns that then instead of linear plus exponential, you get logarithm plus another term that's relative risk aversion higher than 1. I find that utility very, very, very appealing because then it will have that aspect of not wanting to go bankrupt and having the same properties you have shown today, but in a multiplicative world, which I also find appealing because I believe that your risks will grow proportional to your wealth. If you take a long run view.
Yeah, no, when I wrote these papers, in particular, I think the one was called Risk and Return or something. The second half of the paper was all about translating this all into multiplicative gambles. You can take the papers I wrote on this stuff and do word processing and substitute multiplicative for additive, and and everything goes straight through. And it is one thing, obviously, that has separated the decision analysis world and the finance world is that we've always tended to look at additive gambles rather than multiplicative. And I agree with you that multiplicative is probably more relevant to the rest of the world and probably will get us more attention if we dealt in multiplicative. But there's a one-to-one correspondence between the results I've shown you here and that world.
Thank you, Manel, for the question, and thank you, David, for the great answer. I think there are some observations by Robin. Robin, would you like to talk about them?
Well, okay, so the first one was just that the notion of that the parameter C as intrinsic risk aversion is related to the Dyer and Serene work on relative risk aversion, comparing utility and value. So that was just reminding us. The next one is more philosophical, but when I think about gambles over health, I'm not absolutely sure that it's just a psychological attitude towards risk that is making my utility different from my value. So think about some sort of optional surgery, like a cosmetic surgery. Well, I don't want to do a cosmetic surgery that's optional when there's a chance of death. Now, maybe I'm...
Well, but my value function would put a very big negative number on death.
Well, I feel like if you ask me my value function about all these different health levels, and I tell you, how my health level is, my value function is for, death, my value function for perfect life with, whatever the perfect cosmetic surgery was, and all of the other different levels, if I just directly talk about how good or bad those different levels are, I'm not sure that it'll come out to be the same as my utility function. And it's not just because of psychological thinking about risk. Anyway, that's just my feeling that if you think about
I don't quite. You're right to have reservations. I don't object to that, but I don't quite see the problem. I certainly can see there might be a problem in that issue. But I don't quite see it. One thing I would say is you mentioned the Dyer Serene paper. I think Rakesh on his own, but maybe it was with Jim, wrote a paper that said if you allow the kinds of substitutions I was using, if A to B is the same as C to D, then you can substitute C to D for A to B, like using substitutions of transitions. He showed that you end up with U equals V. And it was a very nice paper. And I know that because I was trying to get the same result and didn't. So I remember very well when that paper came out.
So I just in general agree. Probably in general, a lot of times I think our utility function also may actually be our value function, our strength of preference function. But when you think about health outcomes, it was just very hard for me to think that my utility function differs from value only by psychological aspects.
Mm-hmm. Mm-hmm. Can you, I mean, you know, maybe in the next 15 minutes or something, can you think of an example that?
Well, of course, I'm adding in an extra feature, but you know, if I'm dead and if I had a whole bunch of kids that were relying on me, now that could still be psychological. I'm worried about what will happen to my kids if I die.
Well, no. But I think when I'm assessing your value function, dying has not only a personal consequence, but you've abandoned your kids. That would be part of your evaluation, wouldn't it?
Could be. Anyway, I don't have it fully thought out. I just feel like there may be more in a utility function, in a choice under risk, than just psychological aspects.
Yeah.
David, if I could add something. This is Jim
please.
Hammett.
Yeah.
Regarding sort of the distinction between strength of preference and psychological aspects of risk, one point is that expected utility works under the condition that the utility function characterizes preferences about consequences. Mm-hmm. And all we care about is consequences. We don't care about anything that occurs before the consequence. So depends on how you define these things, but some of the anxiety over risk is an experience you get before the consequence is realized. Some of it is the regret which pertains to what other consequences you could have received. But I think we need to be careful that expected utility will only work in the case where all we care about is the consequence.
Well, yes. If I take a gamble and its resolution is delayed, I may well have anxiety in the period between when I choose to take it and when I know the outcome. That anxiety is part of the consequence. You could say that it may well be true that the anxiety prior to making the choice, the anxiety about the choice, I guess is an outcome, is a common outcome, right, of the fact you've been put in this dilemma. But some of the anxiety will be an outcome.
This is Ralph. I think one thing both of those refer to, you might need multiple objectives to characterize them, and that you have a choice on how you wish to define them. And you could call the outcome only the economics, but then other concerns of the decision process are relevant to include separately, such as regret and disappointment. And so if you just use the utility function on money, and if money was a big deal, then you'd get kind of the point estimates that were indifferent to each of the gambles there. And it might be then easier to then use a value function for those equivalent amounts of economics, point estimates, and other things like regret, anxiety, and things that are being talked about. As a practical matter, I mean, that's how I might try to think of it.
Well, as your student, that's how I think about it too.
Probably I learned it from you.
By the way, just to temporize for a moment, when I agreed to give this talk, I was thinking about talking about all this stuff because I imagined, I really thought that most of the people who might attend would be of the younger generation, for whom all this stuff is ancient history and is worth, reviewing might be the wrong word, but stimulating thought about all these things. And half my audience was there 40 years ago, best I can tell. But I think Ralph says it very well. So where I come out is that when Robin comes up with her example, or anybody comes up with their example, but at the moment I believe that the things that cause strength of preference and von Neumann-Morgenstern utility to differ when they differ in assessments is due to issues that should be treated or could be treated separately, unless in the unusual outcome that somehow those other issues are directly correlated with the wealth outcome. Because otherwise you are concatenating two issues that are not the same issue, I guess. The other, just to riff while you all think of something to say, the business about the unresolved decisions, the options that make the utility function convex, perhaps. It's the idea that you can find some utility function that satisfies all conditions is probably a pipe dream. And that a utility function should be assessed over, a range that's compatible with the problem, and may have oddities in it if they can be explained. Like I have an unresolved decision between X and Y.
This is Ralph. I just have one quick comment related to Robin's a bit, and on cosmetic surgery, and you wouldn't want to do such a thing if there was any chance of death. The thing is, anything we do in the next day has a chance of death. You could go in and get the cosmetic surgery one day and it goes fine, most likely. Whereas had you not gone in, you may have gone for a ride somewhere and been in a car wreck and died. And there just isn't that total zero risk. So it's a good way to think about it. I mean, I would think about it the way you do, Robin, but just the point is there aren't any alternatives if you look at the whole thing that we avoid any chance of dying tomorrow or in the next year or whatever.
Okay, there is an observation by Ilya. I don't know if Ilya, you can say it yourself, or you want me to read it?
No, sure, I can say. So hi, yeah, thanks for the talk, David. I'm sorry, I think I'm missing maybe something here, because I could never understand this, right? That if you have a single attribute, it looks like technically you cannot separate value function and utility function. It makes sense if you have multiple attributes. So with multiple attributes, you can define things like strengths of preference in terms of, you would say, okay, I can put extra 10 hours to move from 100 to 200, and I can put extra 10 hours to move from 200 to 400.
Yeah.
But that's exactly two attributes, right? But with a single attribute, how can I even separate? How can I define? Then what was that about, sort of?
No, you've put your finger on why strength of preference has never gone anywhere. Precisely because the only way to explain why somebody would say, I like A to B better than C to D, is by using a yardstick of something else, like I use how many hours I'm working or whatever. And if that's true, you might as well use the value function of wages and hours worked. But it's the devil in the deep blue sea. People seem comfortable answering questions about strength of preference. And while assessing a von Neumann-Morgenstern utility function is more academically pure and correct, my thesis is, to repeat it, is that the psychological issues sort of get in the way. And I would expect that assessments made using strength of preference with the flaws that you just mentioned earlier would nevertheless be more accurate than those assessed from gambles.
No, but then kind of in some sense, what to do with that, or what people mean by that? Because again, if it is about, let's say, hours, then it seems it will be more natural to model it as bivariate utility, right? I mean, and can always kind of later fix number of hours and then look at preferences over gambles. But then I think everything is resolved, right? But so what I'm just trying to say is that the fact that people are comfortable answering something, but I can't put it into action, it's not clear what to do with it.
So the end result of these reflections would be that every time you make a decision, you have to do a multi-attribute utility analysis over everything, all the consequences of this decision. But the reason we want a utility function is because we don't want to have to do all that. It's too complicated to do, a 25 attribute utility, multi-attribute utility analysis every time you're making a decision. And so the utility function is a kind of a summary, an average, a rough cut assessment. So you don't have to do it. It's a shortcut, if you like, because it's clear that except for small gambles that don't affect your life, just expressing the consequence as an amount of money is not telling the whole story. I mean, I was fumbling over that when I talked about, writing yourself a check for $1 trillion. It's going to change not only your life, but it's going to change the world around you if that happened. And therefore, you'd have to do a multi-attribute utility analysis. It wouldn't make any sense. So your point, Elia, is 100% correct. But both sides have issues. As I say, assessing von Neumann-Morgenstern, you could test people's veracity by giving them gambles, but no one ever does, except for very small values.
Okay, thanks.
Yeah.
I think we have time. I don't know if allows for a couple of other questions. There's one by Philippe Delquet.
Okay.
And another observation by Gilberto. So let's start with Philippe.
All right, Philippe. Hello.
Yes, thank you very much, Manuel, and thank you, David, for the presentation. I have a question about the value of side bets. I wonder if it's correct to think of the value of side bets as capitalizing on the value of perfect information, because it is indeed counterintuitive that as a risk averter, you would accept a side bet that might be not desirable, but the way I thought of it was you're creating uncertainty in your wealth, and then you resolve that uncertainty, and so you get the value of information from resolving that uncertainty. And I wonder if you have thought about it that way, and if that would be the correct way to think of it.
No, I don't think it is the right way. I mean, it's the way, I think I use this example in the paper, but let's say you don't quite have enough money to go to grad school. And so you take a gamble. And if you win the gamble, you go to grad school. And if you lose the gamble, you still don't go to grad school. I don't think it's the value of information. It's that you are in a peculiar position whereby, well, I just repeat the example, whereby clarity is actually adding value, clarity about your wealth.
Yeah, but for the grad school thing, you wouldn't probably take a gamble that has a negative expected value. while it seems to me the value of a side bet, the gamble could have a negative expected value.
Yes.
And yet you benefit, so you have something negative, but the resolution of that uncertainty puts you in a better position. So it's the observation of the outcome, basically, that is now the fact that you will observe the outcome of the gamble, and that leads to a different decision, whether it comes out one way or the other.
Right.
So anyway, I mean, I'm throwing that out. It sounds like there's a connection there between the value of perfect information that we artificially kind of capitalize on by creating a side gamble.
Well, you could phrase it as saying, you know, life's a journey. I have to decide between X and Y. I just wait a bit. I just wait a month. And my wealth is going to vary due to natural circumstances. I don't have to go to Las Vegas to take this trip. In a month, you know, my wealth will be somewhere different, and then I decide. But again, going back to, if I may, going back to what I envisaged this talk doing was, I haven't talked to a grad student in decision analysis in a long time. I don't know what the state of knowledge is, but I think there are a lot of unanswered questions in this area. Despite 40 years of working on it, with a lot of you guys too. The gaps that Ilya mentions and Robin mentions and James mentions, these are opportunities for study. And all the names I don't recognize, who I'm now assuming are younger academics in decision analysis, there's a lot to work on here.
Thank you. So we probably have the last question by Gilberto.
And then I think we should stop, just because people may be anxious to get off and not want to. Anyway, yeah.
I'll give the last one then. Thanks, David. So it's back to Robin's question, really, because descriptively, people do take these optional surgeries. They have some risks and some people die.
Yeah.
So we could explain this, I guess, with risk-seeking behavior, risk-seeking attitude.
Yeah.
But could we explain this with strength of preference? So could you explain descriptively what people are doing?
Well, remember, you know, my argument of extractive preference is that when you calculate expected utility, you should use expected strength of preference. It's not that I'm saying you can do everything without uncertainty. My argument in my last 3 slides is that if you want to assess U, I would recommend doing V. You know, you're still taking expectation over V.
Okay, thank you.
Okay.
Well, thank you very much, David. Really, thank you. Thank you a lot for a great talk and several fantastic insights. And I thank you all the ones who have joined us this, well, depends on where you are, afternoon, midday, or evening in your part of the world. And well, thank you again, David. And the next appointment is for March 23rd at the same time with Manel Bauchel as a speaker. See you all there. Thank you very much.
Bye.
Bye, David. Bye, all of you. Keep safe.
Thank you.
Bye, David. Thanks.
Bye-bye, Bob. It was fun seeing everybody.
Yeah, thank you very much.
I hope more people do this.